Good morning, Year 10. It's Mr. Sun here, just going over the bits and pieces for this morning, which, if you do remember, and if you look at the chart, we were looking at just sort of going over the four major plastic forming techniques. Now, we have been over these before, certainly vacuum forming, which I will go over at the end, and injection molding. Both of those you should be really familiar with. Blow molding and rotational molding might be something that's a little bit new, but what we'll do is we'll go over each one. I have linked to all of these videos, but they certainly do help to show the process. The first one is injection molding. Now, injection molding is a pretty straightforward and simple type of process, and it is actually the major forming process for plastics. Most plastic products that you have in your home have been injection molded. So something will probably be quite close to you now will have been injection molded. It is a fast, efficient, and also very precise technique because it allows a lot of detail. Now you can see on here, this is the animation and it shows the actual mold that's being produced, and these can be very, very complex. You can see there's little pins that push the product out, there's little channels that go through it that allow the mold to be cooled by water, and you can see the water cooling pipes here. We can see the process starts off by the granular bits of plastic coming into the hopper, and these are fed into this rotational heating element. So this has got a rotational screw. As we see here, it's got three individual zones: a feed zone, a transition zone, and a metering zone. The transition zone is where it's heated up really and becomes molten and gets to exactly the right temperature for the injection molding process. So you can see as the motor turns that screw, it's forced into there. It's very similar as well to a hot glue gun, if you think about that, that you squeeze the trigger. Instead, it uses the screw to squeeze the molten plastic into the mold. Now you can see that it pushes it, so it meters it forward, and then it actually forces it using a ram rather than using the screw itself. It then pulls back, and what that does is it makes sure that we don't have it all squirting out there under high pressure. So again, it comes back, forces the plastic into the mold. You can see these blue sections around here are the cooling parts, and the cooling process, being a metal mold, obviously it cools the plastic down very, very quickly. It solidifies, hardens, the pins push it out, and the process can continue over and over again. Now this is a much slowed down process. Literally, you can be making ones of these in, simple products probably in a fraction of a second. Depends on the size of it, the types of plastics, the machine that's being used, and how much coolant is being done, and also the quality of the product that needs to be produced. But injection molding is a very, very simple process. The only problem is it does tend to be expensive to make the molds originally, which means that you need to produce a lot of the item. So there is expensive upfront cost, maybe even hundreds of thousands, but certainly tens of thousands to make the mold because they have to be machined out of tool steel. And then that means that the products that are produced, you have to sell a lot of them because they're generally fairly cheap. If we move on then to rotational molding. Now, rotational molding is completely the opposite in a way, because what it is it's a lot simpler technology. What you have here is a guy, he's walking into the actual mold that is going to be produced, and just like the granules in the injection molding process, he's pouring those granules directly into the mold. Now, this mold is made out of, in this case, steel. And you can see that he's adding a colour there because they obviously want a darker black kind of plastic. Rotational moulding is usually used for larger items. You can see this is going to be a very, very large item. I think it's something for storing oil. So these larger items where the surface quality is not as important. You're not looking for that really fine detail. So things like your big plastic bins that you have at home, they may well have been done using rotational molding because it's such a large product. It's very, very difficult to do it using injection molding machines. They're just not big enough. The actual mold itself is then craned into a heating element, into an oven, so it can be heated up. It's such a large mold, these have to be specially made. So the factory producing items, again, they usually have to fabricate these ovens and the molds and everything else so that they can be used specifically for a product that they're going to make over and over again. So it's not something which is done for one-off small bits and pieces. They turn on the oven, Now this is where the rotational part comes in that the whole thing rotates. So you can imagine that on the inside of this, the granules are starting to become liquid. And then as it rotates, and sometimes they do it not just in 180 degrees, but they do it in over a number of different axes as well. As it rotates, it layers and coats the inside of the mold with all of the plastic. At that point, what happens is, after a certain amount of time and also cooling has gone on, and you can see inside here it also rotates in that direction as well, so you can see that it's rotating inside that and then it moves back and forth. They can turn off the machine, and that's when the actual item can come out. So you can see just here it's just being lifted out. So this is the mold being taken out of the machine. And then craned over, and that's when it'll be separated out. So you're talking a very, very large object, and you just can't do this under any other type of process. And you can see here that they're taking off the lid, which is also pulling out the other part. So it's made almost a replica of the previous one. And there's the plastic on the inside, fully formed. So it's used a lot of plastic. It's a heavy item. It's a very large item. So rotational molding tends to be used for these kind of rougher types of items. And is therefore sometimes quite a bit cheaper. We then have blow molding. Now this is part way through the process on blow molding. Blow molding is very, very similar to injection molding. You do have, it's a very rapid process. It's expensive to set up, but it can produce many, many items. I mean, you can see you've got 4 of these sprues coming out here. What happens with these, you've got the injection parts here where they've squeezed out these cylinders of plastic because they're hollow on the inside. And what happens is, as they are squeezed out, the molds that you can see clamp around them. Now, I don't know if you saw that just then. If we just come back a little bit on there. But you can see as the molds come up, these are actually molds for the bottles. And what these can do is then to start to compress and squeeze that slightly molten and malleable plastic, because it is heated, into the shape. They do that, and then can you see that what happens is a little funnel piece comes down in and blows the body to fill the full gap. So it forms the full part of the bottle. So in other words, what it does is it expands it out like bubblegum that you would blow out. It blows out so it fills the full mold, and hence why it's called blow molding. This is very, very good for making bottles and other hollow items. All of your plastic bottles, water bottles and things like that will be done using this, and it's a very, very quick, effective and quite efficient process. Again, it does cost quite a bit of money to make the molds, just like it does with injection molding, but you're working on the idea that you're going to make many, many thousands, millions of these, and therefore for the unit cost it recoups them. And you can see just on here, this is where it just slices off the tops, the excess, and that excess can go back into the process because it's a thermoplastic, and it can go back into the process and be used again for further further blow molding processes as well. You can see here it's just doing a test there to just make sure that there's no holes, and then they're ready to be filled. Simple as that. So that's blow molding. Very, very straightforward. And finally, the one that you're all familiar with, and the one that we've used quite a bit in the workshop, because we obviously have got a vacuum forming machine. Now, a vacuum forming machine works in a similar way to the other processes in that you have a mold. In here we've got the beetle, and it's lowered down into the drum, and a piece of usually polystyrene, or high impact polystyrene as it's called, is clamped onto the top. Now, what a vacuum former does is it sucks the air out of this bottom piece just here. And when it sucks that out, the pressure forces the plastic around the outside. So that forcing is not because it's being sucked down onto it, it's because the air around the outside is pushing in because there's a vacuum on the inside. So there's a negative pressure on the inside of the machine, which means that the higher pressure outside pushes the plastic into place. And that pretty much is vacuum forming. Vacuum forming can be used for larger items. It's not tend to be used for very, very high level items because you've got the problem of that edge that you need to remove. But things, for example, like acrylic baths and things like that can be done using vacuum forming, and that can be a very, very useful process to do that. Again, it still needs to use the heater to heat the plastic so it becomes malleable. If you try to do that before actually heating it, it wouldn't move at all. You can see that there is the problem with the edge, because you're always going to get an edge around the outside of the product, and that's where it has to be cleaned off. And that's one of the reasons. And also, you can't do a completely three-dimensional item. But if you imagine microwave meals and other sort of containers that you have for a lot of your food stuff, a lot of those are actually vacuum formed because they only need to be in that sort of 2D kind of shape. And so things like that, jelly molds, that type of stuff, it's perfect for that one. And it's a very, very cheap process because the molds can be made out of relatively cheap resin or even wood. And that means that they can be made very, very quickly indeed, even 3D printed. So creating a vacuum form mold is both quick and also very, very easy indeed. So that's vacuum forming. So those are the 4 individual processes that I'd like you to just get some notes on today. What we're looking at on Wednesday, I will do a live drop-in session. That will be from 10:30. I will put that into the diary and I'll just post about that on there as well. So at 10:30 on Wednesday, I will be there for just a drop-in session. We're going to be looking at third angle drawing again and doing those, and I'm going to have a little bit of an assessment. I'm also going to have a look at what you've done previously on the shaping of metals and do a video to sort of give you some feedback on some of those from that lesson. So that's going to be one thing I'm going to do, and I'm going to share that video on the main post part. So keep an eye out for that one. That will be coming on later today. And what we'll do is we'll have a look at everybody's work and just sort of compare and contrast and give you some general sort of feedback. Okay then everyone, thanks for watching and I look forward to seeing those notes on these ones. We are getting very close to the end of the sort of theory bits and pieces, so hopefully see you soon. Take care and I look forward to seeing what you produce.